In this concept, we're going to talk about dividing polynomials. Now, dividing a polynomial by a monomial uses the same skills used in dividing monomials, right? So in this case, we use the exponent rules. Let's look at this example. So simplify this expression. 6xy squared minus 3xy plus 2x squared y divided by xy. So this is the same as a sum of quotients, right? So we simply separate each of these terms, each of the terms in the numerator, with one denominator, right? So we'll have this, and then we'll have this, and then we'll have this, right? Just, subtracted, added, just the same as this sign right here, which is exactly what we have right here. So we have 6xy squared divided by xy minus 3xy divided by xy plus 2x squared y divided by xy. And here we just divide, right? We just cancel the common terms, so the x's and y's. This is very similar to simplifying fractions, right? If you had 3 over 9, right? So, 9 is essentially 3 times 3, right? So this is the same as having 3 over, 3 times 3. So divided by 3 is 1, divided by 3 is 1, so this is the same as 1/3, right? So in this case, it's the same. So we just simplify similar terms using exponent rules. So here we have 6xy squared divided by xy. X's cancel, right? And then this y cancels with one of these two y's, right? So we have 6y minus 3xy divided by xy. So x cancels with x, y cancels with y. So we have 3 minus 3. And then plus 2x squared y divided by xy. Y cancels with y, x cancels with one of the x's. So we have 2x. Okay, so we have 6y plus 2x minus 3. Let's look at a division algorithm for dividing a polynomial by another polynomial, right? So in the previous example, we looked at we looked at dividing a polynomial by a monomial, okay, single term, right? So here, xy here was a monomial, single term. But what if we have a polynomial now in the denominator? So another way to divide a polynomial by a polynomial with more than one term is to use the division algorithm, aka long division. Okay. Now I know most of you hate long division, okay, but it doesn't have to be so hard. The main issue with long division with everyone, the main difficulty is that students do not practice it enough, okay, but it does not have to be difficult. So we'll look at how to carry out this algorithm right now. When doing the division, add or subtract like terms only as shown in the example below. So keep this in mind. Let's look at this example. Use long division to find x cubed plus 8x squared minus 20x divided by x minus 2 in parentheses. Okay, so we can write it out like this in a long division form. And the way the algorithm progresses is it's basically cyclical, right? So start with the first term of the of the big expression. So then take this first term, divide by this first term, you're going to get something, right? So x cubed divided by x is x squared. Then take what you get here from that specific step and then multiply by each of those two, right? And then just write it down here. Right? So the 2 becomes 2x, right? So again, let's look at how this works. So 8x cubed divided by x is x squared, and then multiply x squared by both of these terms. So x squared times x squared times x is x cubed, right? And then x squared times negative 2 is minus 2x squared. It's the other term. And then now that you have this, subtract this from the top term. Okay, just do a simple subtraction. So you'll see x cubed minus x cubed is 0, right? And then 8x squared minus negative 2x squared. So remember, two negatives is a positive. You have to take these into account, which is 8x squared plus 2x squared, which is 10x squared, right? And then the minus 20x, there's no x term here, so the minus 20x just drops down as is, right? So you end up with 10x squared minus 20x. Now hold this thought, okay? We still have to do an additional step, just like we did, just like what we did, okay? So take the first term here, which is 10x squared, right? Divided by the first term here, so 10x squared divided by x is just 10x, right? Take what you got and then multiply by both of these terms again, right? So 10x times x is another 10x squared. And then 10x times negative 2 is minus 20x. Look at that. How convenient, right? And then once we've done that, then again, just subtract this from the first term the first expression that you had above it. So when you do the subtraction, 10x squared, again, we're simply subtracting like terms, right? Not just because they're on top of each other, but because, you know, they are like terms. So 10x squared can only be added or subtracted to the 10x squared to this term. So 10x squared minus 10x squared is 0. And then minus 20x minus negative 20x, right? So minus 20x minus, and then the negative 20x, right? Again, be very careful in distributing these signs. Do not forget these signs, which is minus 20x plus 20x, which is 0. So this is another 0. So 0 plus 0 is just 0. Now, since there's no remainder, okay, the remainder is 0, so you have just carried out this division. Okay, so x cubed plus 8x squared minus 20x divided by x minus 2 gives me x squared plus 10x. Okay, with the remainder 0. To check the answer, we can very simply multiply the result by the x minus 2. Okay? So I'll let you do that on your own, but you should get back to this expression if you do that. Okay? Now we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so let's look at what we have. We need to divide these polynomial expressions. So here we have ab squared plus 3a cubed b cubed minus 1 divided by ab. So like we said here, this is essentially a sum of quotients, right? So what we do is we just separate this expression, this single fraction, into 3 fractions, or 3 quotients, right? ab squared divided by ab, and then plus 3a cubed b cubed over ab minus 1 over ab. Which equals, we can simply now reduce this. So a divided by a goes away. Cancel one b with one of these two b's, so we have a b from this expression plus a cubed divided by a. So again, division, subtract the powers. So 3 minus power 1 is power 2. So the 3 remains the same because there's no number to divide it. So 3a power 2, and then b, cancel one of the b's with this becomes, again, so b cubed is b times b times b, right? So we cancel one of the b's in the denominator with one of these b's, so you have b times b, which is b squared, right? Minus 1 over ab. And this is my result. Okay, next exercise. 2x squared plus 3x minus 5 divided by x minus 1. So again, just write out the division form, right? So we have 2x squared plus 3x minus 5, and then divided by x minus 1. So again, follow the algorithm just the way you were taught, okay? So take the first term, 2x squared, divide by this first term, right? So 2x squared divided by x is just 2x. And then take the 2x, multiply by these two, and then just write it here. Okay? So 2x times x is 2x squared. 2x times minus 1 is minus 2x. Okay? Put it in parentheses. And then subtract. 2x squared minus 2x is 0. 3x minus negative 2x, which is 3x plus 2x, so that gives me 5x, right? And then the minus 5 is just minus 5, because there's nothing else to subtract it from, or add it to. Now take this first term, again, divide by this first term, right? So 5x divided by x, and then just write it here. 5x divided by x is plus 5. Now take the 5, multiply by both of the terms, right? And then write it out here, right? Okay, so 5 times x is, let's remove some of these arrows so we have space. 5 times x is 5x. 5 times negative 1 is negative 5. Look at that. So, and then just subtract these two from each other. 5x minus 5x is just 0. Minus 5 minus negative 5. So minus 5 minus negative 5, which is minus 5 plus 5, which is 0. Okay? So 0. So the total, the end result is 0. Remainder is 0. So lo and behold, this is our result from dividing 2x squared plus 3x minus 5 divided by x minus 1. So that gives me 2x plus 5. Okay? Hopefully this was clear. This is it for this concept. See you in the next video.